Alright, so in this video, we'll be looking at this question. So the question here is, a sample of an organic compound contains 0.624 gram carbon, 0.065 gram hydrogen, 0.346 gram nitrogen, and 0.208 gram oxygen. A. What is the empirical formula of the compound? B. If the relative molecular mass of the compound is 194, what is the molecular formula? So we're given the relative atomic mass of carbon to be 12, the relative atomic mass of hydrogen to be 1, the relative atomic mass of nitrogen to be 14, and that of oxygen to be what? 16. So again, the question is, a sample of an organic compound contains 0.624 gram carbon, 0.065 gram hydrogen, 0.364 gram nitrogen, and 0.208 gram oxygen. A. What is the empirical formula of the compound? So the first thing that we want to do here is to answer A, to look for the empirical formula. Alright. So in looking for the empirical formula of a compound, there are two things that you do. Number one is to look for the mole of each of the atoms or each of the elements that are present in this compound, and secondly, you divide by the smallest mole. All right. So what are the elements that are present in this compound? We have 0.624 gram carbon, we have 0.065 gram hydrogen, we have 0.364 gram nitrogen, and 0.208 gram oxygen. All right. So we have carbon, we have hydrogen, we have nitrogen, and we have what? Oxygen. These are the four elements that are present in this compound. So the next thing I will do is to look for the mole of each of the elements that are present in this compound. So mole, you should know that mole is equal to what? Reacting mass, all right, over molar mass. So what is the mole of carbon that is present in this compound? So the mass of carbon is what? Is 0.624 grams. All right. So that's 0.624 divided by the relative atomic mass of carbon, which is 12, divided by 12. Then that of hydrogen is what? The mass of hydrogen is 0.065 gram. That is the reacting mass of hydrogen in this compound. So that is 0.065 divided by the relative atomic mass of hydrogen, which is 1, divided by 1. All right, then let's calculate the mole for nitrogen. So again, mole is equal to reacting mass over molar mass. So the reacting mass of nitrogen in this compound is what? Is 0.364. All right, 0.364 over the relative atomic mass of nitrogen, which is what? Which is 14. Then that of oxygen. The reacting mass of oxygen in this compound is what? 0.208. So that's 0.208 divided by the relative atomic mass of oxygen, which is what? 16. So when we divide, 0.624 divided by 12 will give me 0.052. All right. 0.065 divided by 1 will still give me 0.065. All right. Then 0.364 divided by 14 will give me 0.026. Then 0.208 divided by 16 will give me 0.013. All right. So these are the moles that I've gotten. Then the next thing that you're going to do is to divide by the smallest what? The smallest mole. Is to divide by the smallest mole. So out of all these numbers, what is the smallest? Which is the smallest? The smallest is what? 0.013. This is the smallest out of all of them. All right. So I'm going to divide by the smallest. So this will be 0.052 divided by the smallest, which is 0.013. Then this is 0.065 divided by the smallest, which is what? Divided by 0.013. This is divided by 0.013, and this is divided by 0.013. All right. So what I did here is to divide by the smallest. So 0.052 divided by 0.013 will give me 4. All right. If you press that in your calculator, you are going to have 4. Then 0.065 divided by 0.013. If you press that in your calculator, you are going to have 5. Then 0.026 divided by 0.013, division will give me what? 2. Then 0.013 divided by 0.013 will give me 1. All right. So this is the ratio of carbon to hydrogen to nitrogen and to oxygen in this compound. So we have 4:5, ratio 2, ratio what? 1. So we have 4 carbon, ratio 5 hydrogen, ratio 2 nitrogen, ratio what? Ratio 1 oxygen in this compound. So therefore, the empirical formula, let me represent that as EF. The empirical formula of this compound is C4H5N2O. Alright, so this is telling you that we have 4 carbon, ratio 5 hydrogen, ratio 2 nitrogen, ratio 1 oxygen in this compound. This is the formula that shows the simplest whole number ratio of the atoms of each of the elements in this compound. Alright, so this is the empirical formula. So again, in looking for the empirical formula of a compound, there are 2 things that you do. Number 1 is to look for the mole. Then number 2 is to divide by what? The smallest mole. So the next question here is, if the relative molecular mass of the compound is 194, what is the molecular formula? All right. If the relative molecular mass of the compound is 194, if the relative molecular mass of the compound is 194, what is the molecular formula? All right, so we'll look at this in the next video.